We are going to continue to solve quadratic equations and inequalities. We are on example 2 where we're solving a quadratic equation using a square root. All right, so we're given 2/5 times x plus 3 quantity squared equals 5. And it says solve using square roots. So the first thing we need to do is get rid of anything outside the parentheses. So 5 divided by 2, 5 halves. All right, that becomes 10 over 10, so that cancels. That equals 1, so it just kind of goes away. Anything times itself, so a fraction times its reciprocal is going to equal 1. All right, so on this side, I've got 5 over 1. So this one's going to be 25 over 2. 5 times 5 is 25. 1 times 2 is 2. All right, now if I solve using the square root, I'm going to take the square root of both sides. So I'm going to have x plus 3. So the square root cancels the squared term and leaves just x plus 3. But when I take a square root, I have to have a plus and minus. So I'm going to have two answers here. So I'm going to have 25 over 2. And now I'm going to subtract 3 from both sides. And what I'm doing is trying to get x by itself. That's how we solve for x. So we're going to have negative 3 plus or minus square root of 25 over 2. So square root of 25 over 2, we can use the quotient property of square roots to rewrite this as the square root of 25 over the square root of 2. So we have x equals negative 3 plus or minus the square root of 25 is just 5. Now this is over the square root of 2. So we don't want to leave this with an irrational number in the denominator, so we have to rationalize by multiplying by the square root of 2 over the square root of 2. All right, so you can see because the square root of 2 divided by, it looks like a negative. That's not a negative. That's just kind of messed up when it copied over here. So the square root of 2 divided by the square root of 2, this should be the bar that's on top of the square root. Square root of 2 divided by the square root of 2 equals 1. And if you take the square root of 25 and divide it by the square root of 2, it does not change if you multiply it by this number. All right, so again, this looks funny because instead of a square root, it looks like a negative 2. It's not. It's just talking about this right here. All right, so it's not changing anything. We're just rewriting it. It's like a different form. All right, so I'm going to have negative 3 plus or minus. I'm going to have 5 times the square root of 2 over, and the square root of 2 times the square root of 2. The reason we chose to multiply this is because now it will be a perfect square, and it will come out from underneath the radical. So 2 times 2 is 4. Square root of 4 is just 2. All right, so this is actually our answer. All right, that's a little bit hard to read, so I'm going to write it over here a little neater. X equals negative 3 plus or minus 5 square roots of 2 over 2. Example 3, solve a quadratic equation by factoring. So each of these, we're solving a quadratic equation. We're just doing it using different methods. And hopefully you're going to learn that depending on what the equation looks like, that's what method you're going to choose if you get to choose. So this says equals 45, so I'm going to say minus 45 equals 0. So the first thing you need to do is set it equal to 0. It tells us to solve by factoring, so we know we're going to go to factoring. And x times x equals x squared. What multiplies to give us 45 and adds to give us negative 4. All right, so think 45, 9 and 5 comes to mind, and they are 4 apart. So if I do 9 and 5, and then opposite signs, because to multiply to get a negative 45, you have to have opposite signs, and I need my bigger number to have the negative. That's how I get the negative in the middle. So negative 9 plus 5. And double check if you're not sure. X times x is x squared plus 5x minus 9x gives me negative 4x. Negative 9 times positive 5 equals 45. And I've said this before, the better you are at multiplication, the better number sense you have, the easier factoring will be. So if you're not good at multiplication, that's something you should definitely practice. All right, so I'm going to have x minus 9 equals 0. X plus 5 equals 0. I'm going to add 9. X equals 9 minus 5. In each case, I'm solving for x using my zero product property. Okay, so when you have the product of two expressions equal to 0, then both expressions equal 0. So all you have to do is set a times b equals 0, then set a equal to 0 and b equals 0. That's what we did. X minus 9, we set that equal to 0. X plus 5, we set that equal to 0 using this zero product property. So we have solved this quadratic equation by factoring, and x equals 9 and x equals negative 5. So those would be the roots of this quadratic equation. Example 4, finding the zeros of a quadratic function. So again, we're finding the solutions. So we're going to have f of x equals 2x squared minus 11x plus 12. So we're going to have 2x squared minus 11x plus 12, and I can set that equal to 0 and solve. So here I'm going to try to factor. So I'm going to have 2x squared and then plus 12. So what I'm going to do is multiply a times c and add to get b. So again, we factored a lot in Algebra 1. You do factor a lot in Algebra 2 as well. You may have factored some in geometry. I don't know how much, but factoring, again, so important. When this number is greater than 1, you have to multiply this times c. This is a, b, and c, remember. A times c, 2 times 12 is 24. And now add to get b. So I have to multiply to get 24, add to get negative 11. So what are my factors of 24? 1 and 24, 2 and 12, 3 and 8. 3 and 8 give me 11, so that's probably what I need. 4 and 6. 3 and 8 is what we're going to do. So to multiply to get a positive 24, I've got to have 2 pluses or 2 negatives. In order to have a negative 11, both of these have to be negative. So what I'm redoing is rewriting negative 11x as negative 8x and negative 3x. Now, I purposely switched the order of these because 2 and 8 are common factors, 3 and 12 are common factors. So all I did was bring down the first term, bring down the last term. I rewrote the middle term by doing a times c, add to get b. All right, so that gave me these two numbers here. So I rewrote negative 11x, negative 8x minus 3x. You can say that adds up to give you negative 11x. But now I have 4 terms. When I have 4 terms, I can group these and pull out my GCF. So 2x squared minus 8x has a common factor of 2x. And I'm left with x minus 4. My next binomial, negative 3x plus 12, I can factor out a negative 3, and I'm left with x minus 4. All right, so negative 3 times x, negative 3x, negative 3 times negative 4 is plus 12. So again, all I'm doing is rewriting this expression as this. All right, now I have a greatest common factor here. X minus 4 is my greatest common factor. And I have 2x minus 3, 2x here, and negative 3 makes my second factor. That equals 0. All right, set each factor equal to 0 and solve. And I get add 4 to both sides, x equals 4. Add 3, and then divide by 2. X equals 3/2. All right, so it's easy to check this. One way to check it is we just finished graphing. You could graph this and see if your intercepts are at 4 and 3/2, which is the same as 1 1/2. You also can take this number, plug it back in, and see if you get 0. Take 3/2, plug it in for x, see if you get 0. Both of these are solutions, so that's 2 different ways that you can check yourself. Again, if you need more practice on factoring, that's something that you should practice. The better you get at factoring, the better you're going to be at a lot of things as we go through this year. All right, you can find extra practice on Khan Academy. Reach out. I can open some more stuff on Delta Math, or just search the internet and there should be lots of stuff on factoring. But again, factoring is so important and it's something that you have to be good at. And you may be a little rusty if you haven't had Algebra 1 for 2 years. Example 5 says solving a quadratic equation using the quadratic formula. All right, so we have x squared plus 3x. Again, 5's on the wrong side, so we're going to subtract 5 and set it equal to 0. So we know A equals 1, B equals 3, C equals -5. Okay, quadratic formula right here. So we're going to have x equals -b, so that's going to be -3, plus or minus the square root of b squared. 3 squared is 9, minus 4 times a times c. And all of that's over 2a. And we're just going to simplify. Okay, so we're going to simplify under the square root. 4 times 5 is 20, and the two negatives make that a plus 20. So 20 plus the 9 is going to be 29. So we're going to have the square root of 29 over 2. All right, and since that is, since 29 is not factorable, 29 is a prime number, so we can leave that. This does represent two solutions. It represents -3 plus the square root of 29 divided by 2, and -3 minus the square root of 29 over 2. But very often you'll see it as this right here where it says plus minus. And that's it. That is your two solutions for this quadratic equation. All right, there is a self-assessment here. I want you to pause the video and try to work these on your own, then come back to see how you did. So just pause the video. You can see the questions, so I'm not even going to read them to you. Just work these in your guided notes and then come back and check your answers. All right, A part, you needed to subtract 14 from both sides, multiply both sides by 3/2, which is the reciprocal of 2/3, then take the square root of both sides. You get the square root of 9, so take the square root of 9 plus or minus 3. So x equals 3, x equals -3. That's your two solutions. B part says to factor, so we've got x plus 5 and x plus 7. Set each factor equal to 0 using the zero product property. And you get x equals -5 and x equals -7 as your roots or solutions. All right, C part, we set this one equal to 0, so 0 equals x squared minus 8x. I can easily factor out an x. So A times B equals 0. Use the zero product property. X equals 0, and x minus 8 equals 0. Add 8 to both sides, I get x equals 0, and x equals 8 as my two roots or solutions. D part says use the quadratic formula. Hopefully you just plugged in your numbers there. Simplify, we got square root of 20. Remember 20 is 4 times 5. 4 is a perfect square. The square root of 4 is 2, so that can come out. Square root of 5 stays underneath the radical. 6, 2, and 2 all are multiples of 2, so if I reduce those all by 2, x equals 3 plus or minus the square root of 5. This is the simplest answer, or the simplest form, so you do need to reduce these as far as possible. All right, I hope you did well. If you have any questions on these, please reach out.